percentiles and Box-and-Whisker plots. These are two things that, again, like standard deviation and variance, are going to tell us how spread out our data is. Let's start with percentile. A percentile, kind of like the median. A percentile will tell us what amount of the data values are above and below a certain number. Here's an example. When we rank map test scores, you'll see this a lot in standardized testing. We've got 10 scores from lowest to highest. If we found the median, it would be 236. And we say that the median is a 50th percentile score because 50% of the scores are lower and 50% of the scores are higher. Similarly, like a 203 would land right here. That's a low score compared to all these others. A 203 would be considered a 10th percentile score. So that number is going to tell us what percent are lower than that score, which also means that 90% of the scores would be higher. Let's think about this one. If you scored a 256, that would land right in here on the list. What percentile would you have scored in? Percentile measures what percent are below that score. So 1, 2, 3, 4, 5, 6, 7, 70th percentile. That's an abbreviation you could use. 70th percentile, meaning 70% of the scores are below a 256. When you hear the word quartile, you probably think of 4, and if you split 100% of the data into 4, that's 25% each. So the quartiles are the same thing as the 25th, the 50th, and the 75th percentiles. So we would call quartile 1 the 25th percentile. Quartile 2 is actually the median, the 50th percentile, and quartile 3 is the 75th percentile mark. So if you were talking about 1,000 scores, you would be talking about 25% of the scores in each of these categories. And actually our Box-and-Whisker plot is going to follow this model where the lowest score and the highest score will be represented as dots. The box will be formed around the middle 50%, and those whiskers will take care of the 25% on either side. Now, depending on how the data is distributed, you'll see that those will be more skewed. Another little vocab word, the interquartile range. Remember, the regular range is the highest minus the lowest. The interquartile range is quartile 3 minus quartile 1. It basically just tells us the span of the two boxes in a Box-and-Whisker, the middle 50% of the data. And finally, our Box-and-Whisker plot, a chart that shows the spread of the data by showing the position of those quartile divisions. So step 1, we want to find those quartiles. Here I've got 13 scores, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and I can see that my median, otherwise known as my quartile 2 score, is a 13. And then what I do to find quartile 1 and quartile 3 is I take whatever is below quartile 2, so I'll be focusing on these scores, and I'm going to find the median of those. There's 6 scores, so my median will land right here. We can say that quartile 1 then is 11.5. Same thing for quartile 3. I'll take what is above the median, and I'll find the median of those. So here we've got quartile 3 is 15. Just a note, if that median hadn't been an actual data value, had it been between two values, then we would have included it when we looked at either the lower half or the upper half. On to the Box-and-Whisker. Step 1, you'll want to make a number line, and obviously it's a number line, so our numbers will be evenly spaced. And I started at 9 because that was my lowest score. Looks like I didn't need all of those. So the Box-and-Whisker plot. So the median is represented, quartile 2 is represented by a vertical line. quartile 1 as well, and quartile 3 represented as a vertical line, and those three values make up the box in the Box-and-Whisker. And then we're going to put a dot at that minimum value, a dot at the maximum value, and that makes up the whiskers. That's how we construct a Box-and-Whisker plot. Just to be a little more clear, we could certainly label those quartiles and the max and the min. Now, since there were 13 scores in this class, it was impossible to split 25, 25, 25, 25%, but that's what each of these segments of the Box-and-Whisker plot represent. So the fact that this part is wider than this part doesn't mean there are more values in that part. It means that these 25% of values are more spread out than these 25%. 25% approximately of our values should be in each of these sections. So again, Box-and-Whisker plots are really good at showing us how the data is spread out. This is another class period's worth of geometry scores, and I just want to think about what can we see, what can we tell from this Box-and-Whisker plot. First of all, can you tell me in which of these spots did most of the people land? And that's a question that tricks a lot of people. Remember that 25% were supposed to have landed in each of those areas. So that was a trick question. In which of those areas did most of the people land? You should have said that they were spread equally into those 4 regions. The width only tells us how much that 25% is spread out. So this 25% of the scores were spread out more than this 25% of the scores, but the same number were in each spot. What information can and can't we tell from this display? We can tell how the scores were spread out. We can tell the lowest and the highest scores. We can tell the median. We can tell quartile 1 and quartile 3 in addition to quartile 2. What can't we tell? We can't tell what the mean is, and we can't tell what the mode is. I would suspect the mode might be in here, since so many of the scores were clustered so tightly in that area, but I wouldn't be able to know that for sure. Since I have the max and the min, I could calculate the range, but I would need individual data values to find the standard deviation or the variance. I can't tell how many students are in this class period. And even though I know the max and the min, those are really the only 2 scores that I know. I don't know the actual individual numbers. Why would this kind of display be helpful for me? I think I would probably pat that class on the back because 50% of their scores were 14.25 or above, and it was a point value of 16, so that's a solid showing from that class period. The other 50% are so spread out, right? And so that shows that my bottom 50% of students, they had quite a variety of number of missed questions. Hey, and just for fun, let's calculate the interquartile range. There's another thing that I can tell. The interquartile range, remember, is the range of that middle 50% of data. So we would take the 15 minus the 10.75. And maybe it'd be interesting to compare that to the full range, seeing that interquartile range is about half of that in this data set, which Just shows me that that middle 50% is pretty nicely spread when you look at the 100% in relation. Here's the actual data from that class. You'll notice that I didn't include that missing score. Can you imagine what that might have done to my box and whisker plot? It definitely would have brought that whisker down a lot lower. I think most of these would probably be spread about the same, but that lowest whisker would probably be a lot longer in that case. I would probably call that score of 0 an outlier. And in the assignment, you'll see a little bit more specific definition of what's considered to be an outlier. Good luck.